In this video, we're looking at BMAT 2020, Section 2, Question 20. So we're told we have a kite, which is PQRS. The angle PQR is 90 degrees here, and that PS is a segment of the line 2y plus x equals 2. We're told that S's coordinates are L, M, and we need to work out what is 2L plus M. So here are all our points of our different points. We've got 0, 1 for P, 0, 5 for Q, and 4, 5 for R. So we're looking for points on a kite. And what do we know about kites? What are the defining features of kites we're going to need to use? So kites have two sets of sides that are the same length and they are adjacent. So to work out which sides are going to be the same, we already have two sides here. We can work out if these are the same length or not. And we can see that both of these have the size 4. So we know our kite is going to look a little bit something like this. We know that PQ is the same as QR. So PS and RS are going to be the same length. So what does that allow us to do? Well, we can have a guess as to where S is. We know it's going to be, let's say, something like a point down here with the coordinates LM. And we know that these two green lines here are the same length. So what does that mean about how we can get from P to S and R to S? We're going to get that in the same way. So that means that this length here and this length there, as well as this length here and this length there, are the same. And those are lengths we can work out. We can just give these arbitrary values for now. So let's call this short section A. What does that make this long section here? Well, that's just going to be 4 plus A. We know to get from P to R is going to be across 4, and then we've got an extra A on the end there, so that's 4 plus A. So now we can work out an expression for L and M in terms of A. So let's start with L. What's going to be our expression for L? So that's going to be our x coordinate. So if we use our x from P, that's 0, and we know we're going across 4 plus A, so L equals 4 plus A. And if we do the same for M, we know that our y value for P is 1, and we're going down an A, so M is just 1 minus A. Now to make this easy for us, what I would do is try and get L in terms of M or M in terms of L. So to do that, I'm just going to say that we know that A equals L minus 4, and we can substitute that into this equation here to get M equals 1 minus L plus 4, or 5 minus L. So we have an expression for L and M now. What can we go from there? How do we work out the actual values of these points? Well, in the question, we know that LM is a point on the line 2y plus x equals 2. So we can actually use our L and M, substitute it into there to get our expression. So we've got 2m plus L equals 2. That's using the x and y coordinates from that point. And we know that m equals 5 minus L. So if we substitute that in, we get 2 times 5 minus L plus L equals 2. 10 minus 2L plus L equals 2. 10 minus L is 2, or L equals 8. So we have a value for L. And from there, we can just substitute it back into this equation here, because we know M is 5 minus L. So that's just going to be 5 minus 8, or minus 3. So now we have L and M. So our final part of the question is asking us what is 2L plus M. Let's just substitute that into there. We're going to get 2 times 8 plus minus 3, or 16 minus 3. So our final answer is 13, and that corresponds to our final answer of F.